All right, so problem 2 from the 2022 AP Statistics Practice Exam. We have a dermatologist that will recruit an experiment. Well, not will, a dermatologist will conduct an experiment to investigate the effectiveness of a new drug to treat acne. The dermatologist has recruited 36 pairs of identical twins. Each person in the experiment has acne, and each person in the experiment will receive either the new drug or a placebo. After each person in the experiment uses either the new drug or the placebo for 2 weeks, the dermatologist will evaluate the improvement in acne severity for each person on a scale from 0, which means no improvement, to 100, which is a complete cure. Right, part A is asking for identifying the treatments, experimental units, and response variable of the experiment. Okay, so the treatments are basically if the participant is going to receive either the medication, so the new drug, or the placebo. Remember, a placebo is just a fake drug. They're still going to think they're receiving the drug, but it's not. It's going to be like a fake dummy pill, we say. The experimental units are going to be the 36 pairs of identical twins. So don't put the 72 individuals because they're looking at those 36 pairs and they're comparing them. They're going to use, well, we're going to talk about this in part B, but just make sure your the units are the 36 pairs because these are like what they're like when they look for subjects. It's not like they're looking for one person at a time. They're looking for a pair of people that are twins. The response variable is going to be the measurement of how much they improved. So that measurement is on a scale of 0 to 100. All right, part B, for each twin in the experiment, okay, each twin in the experiment has a severity of acne similar to that of the other twin. However, the severity of acne differs from one twin pair to another. For the dermatologist experiment, describe a statistical advantage of using a matched pairs design where twins are paired rather than using a completely randomized design. Okay, so my reasoning was essentially because we know that that people respond differently to different drugs, different foods, all sorts of different things, different workouts. We all know that because we can say mainly it's because of our genes. Like I'm not a geneticist, but we can say that since we're all different, slightly different in our DNA, or very different depending on how you want to look at it. In this case, we can argue that, well, how do I know it was due to the treatment or the drug and not just because of the genes of the person? Because maybe there's something in their genes that allows them to respond positively to the drug, or there's something in their genetics that makes it so that they resist the drug or maybe respond like negatively. So it's a factor. It can be a confounding variable, we say. But if we find identical twins, which we know that identical twins are virtually identical in their genes, then it basically takes out that factor, takes out genetics being a factor as to why we have different results in our data. Because again, if you're going to give one twin the treatment, the new drug, and one twin the placebo, then we can actually tell within each pair of twins, like, hey, there was an improvement. Hey, there was no improvement in either case. We can actually rule out genetics being a factor. In terms of how you want to word this, I always try to, approach it as if the person doesn't know what you're talking about. So try to be more specific than not, but don't try to say stuff just to make it seem like you know what you're talking about. So don't BS your answer. You know when you know the answer, and you know when you don't. So just be careful on that, because these graders are could be biased or they're just different as to when they approach or when they're reading over a response. So just make it very objective. They'll make it something that's subjective. All right, and the last part for the dermatologist experiments, for the dermatologists, I really can't say that word, for the dermatologist experiment, describe how the treatments can be randomly assigned to people using a matched pairs design in which twins are paired. Okay, like the most simplest way we can do this is, maybe going back to, you remember elementary school, you put each person's name in a hat and you draw one at random. That's usually like a way we can do random assignment or random selection, even, or random selection in that case, because you can't see the name, and like it's very like a little kid can understand that. You could always do the random number generator, but I would say that you have to be a little more clear and more detailed in writing your response. Like you have to say, you have to maybe within each pair of twins assign each one a 1 or 2. And then I'm worried sometimes, like, how do you know which one to assign a 1 and which one to assign a 2? That sort of thing. But I basically said that for the first pair of twins, write each person's name on a piece of paper and place it into a hat. So just place 2 pieces of paper at a time. Then from those 2 pieces of paper, randomly draw one, and the name you draw is going to be the twin that's going to receive the drug. And the other one is the one that you don't draw is gonna be the one that's gonna receive the placebo. And you repeat this for all the pairs of twins. Well, and I just realized I didn't put will receive the drug. So see, this is why I like doing these videos. So I can catch my mistakes, where the name drawn is a twin who will receive the new drug. Will receive the new drug, and the remaining twin will receive the placebo. All right, so there you go. That's all there is to question 2. So as usual, if you have any questions or comments, leave it in the comments section, and I'll try to get back to you as quick as I can. And I'll see you guys in the next video.